All right, now we are proceeding to section B, where the type of question that you have is not option based. There is a certain value, the numeric value that you need to fill up. Now let's see, what's the first question? The electromagnetic wave. This is one chapter which always has its reservation in JEE main examination. You would find one question almost guaranteed from electromagnetic wave. This time it's a very simple and a straightforward one. The frequency is 5 gigahertz, is traveling in a medium whose relative electric permittivity and relative magnetic permeability both are 2. So epsilon r, mu r, both are 2. We need to calculate the speed of this wave in the medium, which is of course equals to 1 by under root of mu naught epsilon naught into mu r into epsilon r. This is all what we need to do. So when you solve this, it's so simple, and when you find the value to match up with this, you get 15 into 10 raised to the power 7. So the correct numeric value for this would be 15. Now let's go to the second question of section B. The second question is from semiconductor. You could see there is a Zener diode. There are 2 resistances. The supply voltage, that's 10 volt. We got to calculate the current flowing through the 2 kilo ohm resistor. Now you need to understand one thing. First of all, we need to decide whether the Zener has reached its breakdown or not. So for that, there is a very simple technique. Assume that the Zener is not there and find the potential difference across this, because the potential difference across this is the potential difference across the Zener, right? You just find it. How much would that be? That's going to be 2/3, because 2 and 1 would be in series. When you assume the Zener is not there, 2/3 multiplied by 10. So that value comes out to be 6 point something. So which clearly indicates that this Zener has reached into its breakdown, because the breakdown voltage has been specified. Now this test is very, very mandatory. The moment you see the Zener, please don't jump into the conclusion saying that, okay, that the Zener is into the breakdown. Many times the examiner plays a game. So you got to be very careful with that, okay? So at least we verified one thing, that the Zener has reached into its breakdown. That means the potential difference across this will be 5 volt. So this will be 5 volt, because that's a property of Zener. Once it reaches the breakdown, the potential difference across it remains constant. So in that given case, that's going to be 5 divided by 2 kilo ohm. So in that given case, so that comes out to be 2.5 into 10 raised to the power minus of 3 ampere. That is the current, but we have to report it in this form, 10 raised to the power minus 4. So this value would be 25. That's the correct option for question number 2. Question number 3, let's see. Question number 3, a little bit of mechanics. There is an inclined plane which is bent in such a way that the vertical cross section is y equals to x square by 4. That means it's a parabolic one, okay? So this is y equals to x square divided by 4. Now y is in the vertical and x is in the horizontal. That's perfectly fine. The upper surface of this curved plane is rough, and the coefficient of the friction, that is 0.5. Cool. So the value of mu, that is 0.5. Now we got to find the maximum height in centimeter at which a stationary block will not slip downwards. So that means at this given position, if it starts slipping down, so this is the point where the friction acting will be limiting one, or we can also solve this in an alternative way. If I call this as the tangent and this angle as theta, now you would see this theta would exactly be equal to the angle of repose, right? And the property would be the value of mu is equals to tan theta. Tan theta is dy by dx. Does that make sense? Straightforward we are going. Now, what is the value of mu? That is 1 by 2. dy by dx, well, that's 2x by 4. So 2 and 4 gets cancelled, and that comes out to be how much? X by 2. You get that point? So I get the value of x as 1. Of course, it's in meter. So when x is equal to 1 meter, at that point, the block starts slipping. Now when x is 1 meter, the value of y, that will be 1 by 4 meter. So 1 by 4 meter, if I convert it into centimeter, of course, that's going to be 25 centimeter.